Okay, this is Unit 9, Area Figures, Unit 9, Day 1. Your essential question is how do you find the area of geometric figures? So on your Cornell notes, go ahead and fill out your essential question and fill out the topic and objective for the day. All right, so we're talking about area, and first we got to figure out what area is. Area is the amount of space inside the boundaries of a two-dimensional object. Perimeter is the distance around the object. So sometimes people get those two mixed up. So make sure you remember that area is on the inside and the perimeter is the distance around on the outside. So here we have two rectangles. Let's focus on the little rectangle first. Notice I have the little rectangle, and what I did was I counted the number of squares that are congruent size squares inside of the rectangle. So when I counted them all up, I got 24 total squares. And so that would make the area of that rectangle 24. But notice what I could do is I could also count the sides going, this number of squares going down, because I don't always want to count the number of squares. So notice I have 4 squares going down and I have 6 squares going across. So, and then you take that, what's 4 times 6? 4 times 6 is 24. So that's a little bit of a shortcut where you can figure out where what the area is of that rectangle. Now, we were trying to figure out the number of squares, the congruent squares. This is why when we say that the units of an area is always going to be units squared, because we're counting the number of squares. So if it's inches squared, that means what they did was they took the number of inches, square inches inside of that figure. Now, let's take a look at the big rectangle. So we have, I don't want to count all those squares. So what we learned on the small rectangle is that we could take the sides and multiply those. So I counted up 14 and going across is 19. So going by what we learned before, we can say that 14 times 19 is 266. And it'd be units squared. So whatever the units is, if it was centimeters, inches, whatever, it'd be that unit squared. Notice what I'm going to do now. I'm going to take and I'm going to cut this, pretend like I'm cutting this with some scissors, and I cut this into triangles. So notice if I have triangles, what I can do is I can take it and I'll show you. I just cut this in half. And then, so what'd that do to the area? Well, if I cover that up, then the area is half. So in order to figure out the area of the triangle, what you're going to do is take the base of 19, and then notice the other side, the height is 14. And so what we would do is we'd take 14 times 19, and since the triangle is half of the rectangle, that would be our area. Here's some formulas that you need to write down, some basic area formulas. If you'll write this down with the picture, you can fill in that chart on your Cornell notes. We'll start with rectangle, and notice that a rectangle, we have the base and the height, and we already talked about that on the last page. So our area is base times height. That's all you have to do to find the area. Parallelogram, same thing. Area is the base times height. The thing about parallelogram is you have to remember that there's a 90-degree angle to find the height, because we can't use the side because the side is slanted. So that doesn't really give us our height. Remember, height has to have a 90-degree angle. Same thing with triangle. That's a B down there at the bottom if you can't see it. We have a 90-degree angle for the height. So the area is 1/2 base times height. All of these, notice, have something in common, the base times the height. The only difference is with the triangle we're taking half, and that's what we showed you on the last page. Here are a couple more formulas for a trapezoid and rhombus and kite. The trapezoid is, remember that with trapezoid we're talking about, we have two bases. Again, we're looking for the height is a right angle. So we add the two bases together, base 1 plus base 2. Doesn't matter which one you put first. You could put base 2 plus base 1, same thing. And then we times that by the height, and then we take half of it. Remember that the trapezoid is cutting the top of the triangle off. So that's why we have the formula of kind of, it reminds you of the triangle and a rectangle together. For a rhombus and kite, I like that because rhombus and kite both have the same formula. So it's 1/2. D1 and D2 stand for the diagonals, and that's all the way across, even though it doesn't really look like that on the picture. It's all the way across diagonal 1, all the way across diagonal 2. You multiply those two together and then take half of it. That'll give you the area for either the rhombus or the kite. So now let's do some examples. If you'll make sure you're copying these down so that way you have some good examples for your notes. Okay, let's take the first one. The first one is a trapezoid. Since it's a trapezoid, we need to use the trapezoid formula, okay, which is A equals 1/2 B1 plus B2 times the height. So what we need to do first is we need to fill in all the information that we know. We know that B1 is 8 and B2 is 20. Again, it doesn't matter which order you put that in. And the height is 11. So work out the problem, 1/2. Let's add what's in parentheses first to get 28. And then we're just going to, you can punch that into the calculator right like it is, 1/2 28 times 11. So when we work that out, we get 154. Now, let's pretend, because I didn't put this before, that all units are centimeters, so all measurements are in centimeters. So when we answer these questions, we need to make sure we have centimeters and squared. All area, remember, we have to have whatever the unit is squared. And there's our answer for that one. Okay, next we'll look at this one, and this figure is a rectangle. So we use the formula for a rectangle. Area equals base times height. So plug in what you know. We know 13 and 27. It doesn't matter which order you put that in, remember, because multiplication is commutative, so it doesn't matter. So go ahead and work that out. When you punch that in, you get 351. Again, it's centimeters squared. Next, we have a parallelogram. So the parallelogram, the formula for a parallelogram, area equals base times height. Plug in what we know for the base, plug in what we know for the height, and we get 18 centimeters squared. Our next figure is a triangle. So with a triangle, what we need to do with that is make sure we plug in the formula, area equals 1/2 base times height. So we have 1/2 times 8 times 5. So 1/2 of 40, which turns out to be 20 centimeters squared. And finally, we have either a kite or a rhombus. I'm not sure. We don't have really enough markings to let us know on that. So, but we do know that the formula is the same. So I'm just going to put rhombus / kite. Rhombus or kite. We know that the area formula is the same. So we have 1/2 diagonal 1 times diagonal 2. So 1/2 16 times 10. which would give us 80 centimeters squared. So there's all the basic figures, an example of each of the basic figures. Now let me tell you, when I'm grading this on a test, what I'm going to be looking for is 1 point for the formula, 1 point for plugging in, 1 point for the answer, and 1 point for the correct units. So centimeters squared, inches squared, etc. So 4 points total. That's how I'll grade the test and the homework. So make sure that you're putting all 4 of those things down. Okay, if you don't have to put that middle part in there that's showing the work, but you do need to show plugging in and the formula. Okay, so sometimes though we're going to know the area and we need to find the parts. So we have 2 figures here. One's a rectangle, one's a trapezoid. Let's start with the rectangle. What you do is, because it's a rectangle, we know we're going to use the formula area equals base times height. Fill in what you know. We know the area is 273. We know the base is 13. We don't know the height. Well, now we've got it set up like a good algebra problem. So what we need to do is we need to solve for h. So we'll divide by 13. So put that in your calculator. And so we get h equals 21. Now, it's 21 centimeters, not 21 centimeters squared, because we're talking about just the one side, not a two-dimensional figure, just the one dimension of the rectangle. So that would be centimeters, not centimeters squared. Now let's look at the trapezoid. Again, we know that the formula for a trapezoid is A equals 1/2 B1 plus B2 times H. So fill in what we know. We know that the area is 204. Base 1 is 10. We don't know base 2, and we don't know H. We're looking for H because that's what they told us to look for, but we've somehow got to get B2. Well, if you notice up here, they give us a hint. We have, right there, we have perimeter. The perimeter is 62, and remember, perimeter is the distance around. So we already have 10, we already have 13, we already have 15. Whatever those are added to our missing side is going to give us the perimeter of 62. Well, when I add all those up, I get 38. So what I have to do is to figure out that missing side. I know the total has to be 62. So I'll subtract 62 minus 38. And I get 24. So now I can work it out to where I can solve for H. So 1/2 of 34 times H. So 204 equals, I take 17, divide by 17, and so what does H equal? Plug that into your calculator. And we get H is equal to 12. And again, it's going to be 12 centimeters because it's not the area, it's just that one. It's our height, so it's just one piece. So in order to solve, if you know what the area is, plug in what you know. And actually, this is if you don't know the area also. Plug in what you know and then solve for the missing part. If you can remember that, you just use your good old algebra skills, you'll do great. Okay, a couple more examples. Now we have a parallelogram and a triangle. Again, they're giving us the area, but this time notice they want us to find the perimeter. So we still need to figure out what, if you notice, we don't know all the sides. We need to know at least a couple of the sides. So we're going to go ahead and use the area formula, base times height, to figure out the base, because we don't know the base. So 2,508 equals the base times 44, because that's our height. So I'm going to divide by 44 to get what the base is. So plug that into your calculator. And we will get the base is equal to 57 centimeters. So since this is a parallelogram, we know that the opposite sides are congruent. So if the base is 57 centimeters, then this side's also 57 centimeters, and then this side's 48 centimeters, since opposite sides are congruent. Now, in order to find the perimeter, what we need to do is we need to add up all the sides basically. So when we're adding up all the sides, there's a couple ways you can do that. You can just plug it all in. 57 plus 57 plus 48 plus 48. Or you can multiply. 48 times 2 is 96. And then we have 57 times 2. And what we'll do is we'll figure out what 57 times 2 is. 114. We add the 2 together. And it's 210. 210 is our perimeter, and it's 210 centimeters. Because again, we're not figuring out what's inside the squares, we're just figuring out the distance. So the distance around, and distance is always in just whatever the units are, centimeters, inches, feet, whatever. Okay, now with the triangles, we're trying to find the height, 1/2 base times height. We know that the area is 39. 1/2 of the base 13 times the height. So we figure out what's 1/2 of 13. 1/2 of 13 is 6.5. Divide each side by 6.5. Just doing some basic algebra here. 39 divided by 6.5 is 6. So our height is 6 centimeters. So again, just plug in what you know and then solve for the missing part. Definitely good for all of you guys who really like your algebra. All right, those are basically all of your examples and for the whole lesson. What I need you to do now is you do two things. At the bottom of your Cornell notes, okay, the first thing, and it didn't show up very well, so I'm sorry about that, but I want you to summarize in a paragraph today's concept of area. What did you learn or notice? And then in the question box, I want you to write a question to represent a problem to go with area. This could be something that you did not understand, an example that you need more help on, or you can make up a problem like one of the problems that we did in our examples. Just make one up, and then what we'll do is we will practice those with the rest of the class next class. All right, that's all for Unit 9, Day 1, Area of Basic Figures. Please make sure you have all your notes filled out.